Okay, for this lesson, we're going to start taking a look at solving absolute value equations. So we know an absolute value equation is any equation that is going to include an absolute value. Now, these ones are all going to have a variable in the equation. So we're trying to solve for the possible values of x that would make this work. One method we have for this is that we can do it by graphing. Now, when we're solving an equation by graphing, we're going to split it up into two parts. We're going to take the left-hand side of the equation and make that equal to y1. We're going to take the right-hand side of the equation and make it equal to y2. And we know that it's going to balance out when it's equivalent for both parts or where these two things intersect. So I'm going to have my function where y is equal to 8. When I'm graphing out that absolute value, the 2x plus 3, then it's going to look something like this. Oh, sorry. Every single line is going to be 2. So it's actually going to look something closer to this. And then I can see that there's the 2 points where they intersect each other. Now, I have the 1 point that's on the left, which occurs at negative 11 over 2 and 8. And I'm going to have the point that occurs on the right, where it's going to be at 5 over 2 and 8. Now, we know that in the equation, there actually is no y value. That was just something that we created in order to graph it out. So the real solutions are going to be just the x values, where x is equal to negative 11 over 2, or x is equal to 5 over 2. And we could always verify this by putting the values back into the equation where x is, and proving that the left side of the equation is equal to the right side of the equation. Now, this is doing it using the left side and the right side as two separate functions. Or we can do it using the X-Intercept method, where, like with our quadratics, we can move everything to one side of the equation and then just solve for those x-intercepts. Meaning that if we do the X-Intercept method, we're going to move that 8 over and write it all as the absolute value of 2x plus 3 minus 8 equals 0. And then we're just going to say that we're going to graph that in under y1, knowing that when y is equal to 0, or the x-intercepts, is where the solution is going to be. And it's just going to move that entire function down by 8. So it's going to look something like this. And I should still have those x-intercepts that occur at negative 11 over 2 and 0, and at 5 over 2 and 0, which are still my x values. Now, we can have the same thing where it's not just a constant that's on the other side of the equation. We can do it where we have an entire other polynomial. When I do this, I'm going to do the same thing where I'm going to take the left side, I'm going to graph it out. And I'm going to get something that looks like this. And I'm going to take the right side. I'm going to graph it out. And I'm going to get something that looks like this. And then I should see that there's a point where those two lines cross. I can solve for the intersect, and the intersect is going to occur at the point of 2 and 5. Remembering that the only part that's really important is just the x value, where x is equal to 2. For the next example, I'm going to have a quadratic. Now, a quadratic with the absolute value, just like with the linear ones with the absolute value, where it drops below the x-axis, it's going to reflect, which means that I'm going to have something that looks like a big W, where it's going to have its vertex reflected back up to this positive 17. It's going to have the x-intercepts. It's going to come up through there, and then it's going to shoot off into the distance. I'm going to have my second equation, where y is equal to the right-hand side, or y is equal to 8. And then I can actually see that these cross each other 4 times. So I have 4 possible values. I have the 2 values on the inside, where x is equal to positive or negative 3. And I'm going to have the 2 values on the outside, where x is equal to positive or negative 5. And those are my 4 possible solutions for x.